Hey Sigma followers, fans, enthusiasts, owners, just wanted to do a quick little video on our feet. So as you guys know, these are our feet. These are actually our early iterations. This one is, at least, with the individual rubbers versus the solid rubber. But wanted to just quickly explain why we have the design that we do, such as this, where you have float in the foot. Most of you already know, but we're just going to do a little impromptu video, nothing too technical. So I have three types of feet here that we've used in the past. This is one where we mount it to a massive frame like you see here. Right now it's just being used for storage, but massive actuator right there. And the way that this foot would work is it would allow the same kind of play that you see here, but for a 7,000 plus pound vehicle that would be loaded on this platform. So for example, if I give this a good push, you can see that sliding. So the way this foot works is we have a Teflon cup right there. We have another Teflon piece underneath the CNC piece as well. And then we have a Heim joint here that allows for lots of play, more than enough play, for example, so that if one side of the platform lifts, which we'll show in a diagram pretty soon, then it allows for that transition to happen without any kind of binding. So if this was fixed, just like if this was fixed and it could not rotate on an angle, then obviously we'd start getting lift here, and then this edge would start digging into the Teflon. So again, this was properly calculated and designed for a high mass vehicle simulation platform for R&D. The problem with this design, besides it taking a long time, being cut from a solid piece of CNC, being overbuilt, probably having to replace these Heim joints after X number of years from just regular wear and tear, and then keeping this pad clean. Anytime you kind of get anything embedded in Teflon, over time it'll just kind of eat itself away. So there's a little bit of maintenance there involved. Okay, before we go into the DK2 cups, which we're very proud of, this is a much different variation, a little dusty from just sitting on the shelf. But this is one of our backup, as you can see, backup vehicle motion, what we call an FMS, full motion system for a vehicle. So the idea is you'd have 4 of these, you'd put the car on top of it, and again, because a car is similar to like a platform or like a motion system you have here, you would have play, you'd have change in distance between the length and the width. So imagine there's a large tire on here, it's sitting on top, and in particular what it's allowing is it's allowing the vehicle to do this. Okay, so again, cut out of a massive piece of billet aluminum. If we flip it over, very heavy, very robust. Again, you got to keep these surfaces clean, just so you don't get any embedded material in it like this that you want to remove. All the edges are lined with Teflon, properly mated, glued. And then what happens is this would basically go into one of our show cars, and as the show car sitting on the show floor, these little pieces would embed into the carpet, and it allows for proper frictionless movement of the vehicle. Now, if we didn't have this, the tire would absorb a lot of the movement, as we've seen in the past. So we've actually ran a lot of our cars with our full motion cars with low tire pressure on purpose. But if the customer is very particular in making sure that the tires don't sag and it looks proper, then this is one of the solutions that allows a 4,000 or 5,000 pound vehicle with occupants, the movement of the wheels to allow it to move back and forth. So we'll get back to these guys. Let's go to the board. So why is it that we need this kind of allocation? So this is an exaggerated example. It's really a bad diagram. I'm not an engineer, so it is what it is. But imagine the platform is stationary. So this is our platform. These are the 2 actuators. Let's say that's the front, that's the back. And so if you have a heave moment and the platform is moving up and down, there's no changes basically. That would be completely fine. But where the issue comes into play is when we have pitch and roll. So imagine here we would have a pitch, like an acceleration. In this case, you draw this angle of the platform, and as small as this angle is of this platform as it accelerates, it still changes the distance. And it's not just the front actuator, it would be both, but in this case, let's just for demonstration show that what would actually happen is as this distance is shorter because it's elevated, we have to allocate for that movement. Okay, so again, this is a terrible diagram, but it does show you the reason we need that allocation. Now imagine you have the same thing with roll at the same time. So, you know, not only would that move back, but maybe you'll move to the left or the right, depending on where you're rolling with the motion system. So again, from the top, if you're to kind of visualize the same thing, imagine this is a standard chassis design with the 4 actuators in each corner, and then again as it accelerates, a little exaggerated here again, but basically this would shorten as it accelerates, right? Because it's again on this incline or on this angle. So for DK2, we have precisely calculated the amount of delta or variance we need in the cups to make this happen. Any kind of larger motion systems with a lot more travel obviously will need more. Also have to take into account the mounting location, if it's mounted very close to the seat or very far. But this is kind of our latest. And then just to kind of break it down, it's very similar, as you can see, to our other feet. In this case though, it's sealed. So the good part about it being sealed is you don't have to worry about what I said, the Teflon being impregnated with any kind of material and then causing accelerated wear. And then this ball socket basically acts exactly like these pads, where it allows both this kind of a movement, and then at the same time it allows the angle. And then the top pad here acts like a seal and also kind of like a noise damper. So you can see how that works. Okay, so you don't have to take your cups apart. You can kind of see how that moves around here. And all these parts are custom made by us in-house. So we have full quality control, material control, price control of everything, versus trusting somebody else across the continent or anybody else to do this for us. We take a lot of pride in making everything in-house, making sure it's done right, and if there are any errors, we own up to it right away and we fix it, we address it, and we send it out to you all. But that's kind of sums it up. Again, that's the vehicle one, that's a high mass one, but the concepts are all kind of the same. And hopefully that helps somebody out there. If not, it's just a little info session.